Okay, I'm back. All right, so if you look here, this is an example, this image is when you would have a black and a tan strains cross. This is what you're gonna have in your lab, okay? And if you look, you're gonna see a whole bunch of different arrangement of these spores. And yes, you kind of have to look. If you're not sure, then don't count those spores, okay? But you're gonna see some. This is a nice example of a 4 black, 4 white, 4 white, 4 black, okay? But then you're gonna see some where now you can't see this entire spore, but you see you've got 2 black, 2 tan. So you can go ahead and assume that you've got this kind of arrangement, a 2 to 2 to 2 to 2, even though you can't see the rest. Or maybe that's a 2 to 4, because look, it's 1, 2, 3, 4. So I'd probably call that one a 2 to 4. Here's a 2 to 2, 2 here, 2 here. So 2 white, 2 black, or not white, tan, 2 tan, 2 black. So that's an example of where we'd have some evidence of crossover. Now I want to point this guy out. Do you see how he's all tan? We are not going to take those into our calculations, okay? These ones that are all tan or all black are an example of a double crossover, something that we don't need to deal with today. This one, it's 2 white, 4 black, 2 white. So that would be a 2 to 4 to 2, evidence of crossing over. And what you're going to do is record all this on your chart. Okay, which ones had crossing over, which ones didn't. This one's a 4 white, 4 black, no crossing over. Okay, here's another kind of example of a card. You can see the pararethium right here. And then this one, it's kind of a cluster. You can't really see the colors, super easy. So again, remember, I'm showing you this in a drawing and kind of what it would look like. This would be an example, these two, of basically asci that do not have any evidence of crossing over. You have 1, 2, 3, 4, 4 tan, 1, 2, 3, 4 black. Remember, you get 4 because of that last mitotic division that occurs after meiosis. Now here we have 4 black. 1, 2, 3, 4 on this asci, and 1, 2, 3, 4 tan. So neither of these has had any kind of recombination. Remember, that's the fancy word for talking about crossing over. Genetic recombination is what we say occurs when crossing over happens. You need to know those words. Okay, now my computer doesn't want to move forward. Not sure why. He kind of died on me here. So just bear with me as I start it back up. Okay, there we go. All right, so this shows you, I apologize for that. This shows you the diagram that's in your lab of when crossing over would occur. Now, I just tanned that whole thing in black because there was a mistake here. But basically, if you had 2 tans and 2 blacks, remember this, there's a lot of genes on each of these chromosomes, but at the very end is the color. And if crossing over occurred during meiosis 1, this guy, this tan guy, suddenly got the black color for the spore, and this black guy suddenly got the tan color. So now what's going to happen is this guy is going to all of these guys are going to come over after meiosis 2, and we have 1 white spore, 1 spore that has the same, or I should call it tan, but it's colored white. Then we have 1 that actually, because of crossing over, inherited the black spore color. So that's what that's showing. Then we have 1 that inherited the tan spore color. So that's what that's showing. And then this guy did not know crossing over occurred with him, so he's going to remain the black spore color. After it goes through the mitotic division, then we end up with what we see here. 2, and it can be arranged in many different ways, but this is what it's kind of showing right here. It just depends on how the crossing over occurs. You could have any of these 4, but the example that we show here would be this one right here, because you have 2 white, 2 black, 2 white, 2 black. Do you see that? Now, this one would occur if you had different chromosomes. Like for this one, you'd have 2 black on the outside. So that means this guy and this guy crossed over. Does that make sense? So this tan and the black outside black crossed over. So now the tan's on the bottom and the black would be on top, okay? So all of these different arrangements are just saying between these four chromosomes, exactly who crossed over with who, okay? But basically when you look at your slides or your cards that are posted with the assignment, you will have 8 spores arranged. And if they are in a 2 to 2 to 2 to 2, so this would be a 2 to 2 to 2 to 2, or a 2 to 4 to 2, 2 to 4 to 2, then we can definitively say crossing over has occurred, okay? And so this is showing you the recombinant, the crossing over chromosomes. And this shows you see the black's not always exactly black, but you'd have it in this kind of an arrangement. 2 to 2 to 2 to 2, 2 to 2 to 2 to 2, okay? And then you'd have something like 2 tan to 4 black to 2 tan, or 2 black to 4 tan to 2 black, okay? This always confused me, so I just showed you another picture where you could actually see it occurring in kind of with the chromosomes lining up, the crossing over. This would be no crossing over. So this is how after the first second meiosis, this is the way it would go. And then you have the second mitotic division, this random event that occurs that's unique. And then we get this kind of a result, a 4 to 4. Then when we have crossing over, it shows where this guy's got the black color and this middle one has the tan color. So that's where we would get, after meiosis, tan, black, and then we have a mitotic division, and we have 2 tan, 2 black, 2 tan, 2 black, okay? So here's some pictures where we can go over this together. This is an example of what would be crossing over, 2 to 4 to 2. This is an example of crossing over, 2 tan, 2 black, 2 tan, 2 black. Again, this one is all tan. Ignore it. Here's another crossing over, 2 tan, 4 black, 2 tan. And you can do this with your PowerPoint too. The purple strip is showing you the recombination or crossing over. Okay, so here's another one. Now this one is a great example of non-crossover. This is a non-crossover, but now we have this purple stripe going through, showing you that's a 2 to 4 to 2. Now this is a good one as an example. You have a 2 to 3. Tris, could you grab my charger, please? Thank you. Hopefully we can get through this before my computer dies. So this is a 2 to 3. Well, you can go ahead and assume that's going to be a 2 to 4 because you've got evidence that that's what it looks like. Okay? So overall, this was a kind of a not as easy one to see, but see how those two are a little darker and a little darker? So that's why we went ahead and counted that one. Okay? All right, so we'd have a 7 crossing over. And then the ones that haven't crossed over, that's in yellow. And there we go. All the ones in yellow are, thank you. That was very nice. Joe came through. We have 4, Joe and Tristan. We have 4 examples of non-crossing over with a total of 11 asci. Okay? All right, so this again is just showing you the overall picture where you have the ascospores inside of the very, very large perithecium. Okay? So this is what you're going to do. Actually, I'm going to pause this and come back to you with another video.